then I just crop it from quarters 2 with the color. Okay. Yeah. Where is it? Mm, oh, sorry. Okay. I put it into the notepad, then only I crop it. Okay. So by right should have a color. Okay. Color. So it should be a green color if you were to tap in into your VHDL. So when you see green color, it means that it's a command. Anything you can put in, but for this anything that you put in, you remember must put a double hyphen. Okay, 2 dash. Okay, so after finish all this, because your case here, you have to end the case, you have to end the if. You can try to change this one to the clock event and clock, okay, equals logic 1, rising edge. Okay, you can practice all this. And then because here got process, okay, I end the process, okay, and end the behavior. And looking at this, okay, my process here depends on binary in and also the clock in for this particular programs lah. All right, that's sorry. So now see here again. So you find that okay, we separate them and we show it okay on the hardware. Our hardware will be able to tell us the input or the sum of these two here is 28. Of course, when I change the input, okay, combinations on this part, you're going to find that my bin BCD, okay, is going to vary. All right, and the display here will also be changing as you are going to see, okay, at the end of your this part here. So this is the hardware. Okay, this is the hardware. We are supposed to show all these things here in the hardware. Next week, I want you all to come back is for you all to sort of, okay, touch and play around with this set of hardware lah. Okay, now, before you can play to this hardware here, you're going to find that, okay, so it is the quarters 2 here because they have this board diagrams features. So you are going to find that, okay, I am going to draw out this. Okay. First, okay, I come up with my this LPM, my adder, okay, my this adder here. And the output, this is actually linked together, connected together. And this linking here can be done, okay, through the labeling. Okay, you label correctly. So follow exactly the same label. So let me enlarge this one, maybe cannot see clearly. So you find that this one is really cropped, so that's why a bit blur here, okay? So you find that, okay, this LPM adder here, result come out, okay, carry out, I label it as a bin 4, okay, bit 4. This is bin, okay, 3 down to 0. Actually, combine the two here, give you the 5 bits output. And this bin 4, I connect to total here. You see, this is bin bit 4, so same name, bin 3 down to 0. So all in, all this, okay, will be connected to here as the input to the bin BCD. So bin BCD 5 bits, 4 down to 0. So combine these two and come here. It can be done, okay, by using name the bin, okay. So bin, okay, bit number 4, bin, bit 3210. Okay, all are bin. So once this one go in, I am going to break them into 2. And in this case here, I'm actually using a clock to synchronize all the process. In this case, because I want them to calculate by themselves rather than I keep on, okay, changing. So the moment I input the clock values here or, okay, clock pulses here, so you're going to find that, okay, they are going to do the conversion for me automatically. And this output here from this bin BCD will be channeled into 2, okay, the segment which is in our lab 4. Okay, segment is our lab 4, which we are going to do today. All right, their output. This output, okay, this output actually is being put here. Okay, being put to this LED. Okay, but of course, okay, before I can show all this here, I must do some setting. The setting is done here. I tell them that the A3, you connect to this pin, A2 connect to this pin. Don't need to remember. This one, okay, you type this D2 board, okay, pin layout, everything will come out. So we just key in this. So next week, expect you all to key in this and see the output. Okay, so this is the hardware part already. So basically, okay, today we are going to do all these things here. So any questions? Okay, so start doing it. If there is any question, please ask. So I stop recording first. Otherwise, okay, those who see find it very boring, okay? Okay, so please start your quarters 2. If there is any question, please ask. Okay, I'm here, okay, waiting for you to ask. I'm not going to show you how to do it. I hope you all can read the lab manual by yourself. Okay, this is the second lab already. Okay, to all? Class, are you okay? Still remember how to start or not? Okay, go to your quarters 2. Okay, my quarters 2 shortcut is here. Start a new project. Okay, no need to read already. Okay, so well, where you are going to put it? Okay, remember your path. Okay, remember the path that you all created. I think you will follow the over here you find that okay, it is taken as a digital lab 4A or lab 4B, these are things. So lab 4, lab 4A. Okay, so I don't want to create already. I think I already have that one. All right. So I don't want to talk already. So when you all have question, please ask. So today we try to finish everything. Okay, we try to finish at least okay until here. Let me get this thing out a bit smaller. Okay, at least until this part here. Okay, this part well, this is the hardware cannot do already. Okay, so finish until here. And maybe I will get some of you to show me that if you say you have done it. Now, for the case of simulations, okay, you all can follow this one here. Okay, it will be faster than using the how do I say the those are diagrams. Okay, slowly you insert this one. You can copy this. Okay, and then if you want to make any changes, you just change it over here and throw it in again. That makes your simulation very fast. All right. Okay, Adin asked me what is the device name. Do you still remember when I talked about bin BCD that time? I did mention that device name and entity name must be the same. So segment. Okay, segment. File name is segment. Try not to just copy, type type it on your own so you at least got an idea how to start writing VHDL program. Well, common, okay? We learn that we forget, okay? Today, how many people attend the class? Okay, Yin Xian not in. Let's check for the people. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Ming Hang, Yin Xian. Yin Xian. Ming Hang. Wen Jian is here. Huh? Okay. So another one is Ki Bun. 9, 10, 11, 12. Okay. So Yin Xuan, what happened to Ming Hang and Yin Xuan? Any idea? Anyone know what happened to Yin Xuan and Ming Hang? once you finish your lab 4A, let me know. I think you have done, right? So you can try 4B first. Okay, 4B, I would sort of explain a little bit. Lah. All right, so the rest, okay, quickly get it done first. Then one shot when I explain, you all can understand better. I think your LPM and some symbol, how does it look like? Maybe you share your screen. Wait, oh, this is the one that you are having. You add file. Wait, the one that I'm having here maybe is of a little bit older version. I think no problems. Okay, no problems. Label according to what I'm having. Okay, maybe my one is older version, so they give a little bit. Okay, the symbol is a little bit okay difference. Okay, so you try your this one. I think should be all right. Whether it can work or not, okay, we will see under the compilation. Okay. What about the rest? What is this? I think cannot understand your question. Where is it? At the input. Or share your screen.
This one.
Yeah. You enlarge it and see.
You see?
Very small.
This symbol.
Okay.
Not input, man.
The,
This
you
one
mean
here.
the behind one, the bin one to
Yeah.
that one is output what?
Output. It's not
Yes.
this one.
And which one? Oh no, because okay, this is not a real output yet. It's not the final output yet. It's only
Oh.
only part. Okay, because the connection, if you draw too many wire, will looks very messy, isn't it? Remember just
So
now I said they are linked okay by name. Ah,
so like that only. Okay,
yeah,
okay,
yeah,
okay,
yeah,
okay,
yeah.
okay, okay.
Okay,
Alright, alright.
Mm. The rest, do you have any problems, John? How is your progress? Uh, on which the lab? 4A. Can you manage? If not, okay, you share your screen. Now, when there is errors coming out, always solve the first error. Sometimes, okay, you solve one, the very first error, you solve all already. Okay, John, if you cannot manage, okay, share your screen. Zhen Wai, managed to get your 4B? Zhen Wai? Doing. Okay, maybe I explain a little bit, okay, and I record this part here just in case for 3 of them who didn't attend. Okay, let me record this. Share screen first. Present now. Share. Start recording. Start. Okay, in this class, can you see my screen? Now, in this 4B here, we actually trying to combine, okay, those entity or component that we created. Okay, so those are component that we created so far is a LPM at sub 0, okay, sub 0, and this bin BCD segment. All right. Now, in order to be able to sort of combine all these previous entity that we created in this VHDL here, we have to add the file. That means call it up, okay, from our database. Okay. So I skip the part, okay, where you create your this project here. This project that we are going to create here is called top level. Okay, we created this, but right after you create this one, okay, you click this, okay, it's a BDF file, BDF file. So when you create this, okay, you click on this, here will be empty lah. So you are supposed to add one by one, okay, those components that you want to use in this PDF format. So what you do here is go to the file here, all right, and right click on this part, you are going to add. If it's a new one, you add. If it's you make a mistake, then of course you remove the file by selecting whichever file to remove it. So you add, okay. Once you add already, if you follow everything, okay, they will link you to those files whereby you can, okay, browse, okay. So these are the files available, okay. You can pick whatever one. If don't have, okay, then you have to go and find lah, okay. You go and find the file from your database. Okay, in my case, because I already added, so it appears everything. If not, I repeat, go to the browser to go and search for the file that you want to add. Okay, so you are going to add according to all these, okay. And in this case here, the LPM that you are going to add is the file type is a VHDL file, because if you just add in the block diagram file, inside is empty, then they don't know what to do. So they need a code. Okay, they need the code. So the code we actually selected, okay, when we created this LPM here, remember, we make the input only 4-bit. We only want them to do the additions, things like that, okay? Then all these are VHDL file. Top level here is a block diagram schematic. Okay, so once, make sure this is here. If not, please go and look for it, search for it, okay? And with this, okay, you find that when you, this part here, bottom, the file here, all this file will appear. Okay, all this file here will appear. Of course, okay, once this is appear, you can get these plot diagrams available on this workspace here. Add in these inputs, label according to the correct features. Over here, follow exactly. All right, so this is the input of the top level with this symbol. Okay, 1, 2, 3, 4. So these are the 4 input of my top level. Okay, 2 output of this top level. Actually, these 2, remember just now I mentioned, these 2 actually should be connected to here. Of course, you can directly draw the line, make it connected. Okay, make it connected. But if for complex, okay, block diagram, you'll find that this is very messy. All right, so these are quarters 2 block diagram file. They allow you to disconnect them, but they link via the name. Okay, bin, when you use this bin here, bin, okay, and the length must be the same. This is 5 bit. You make sure this one add up is 5 bit. Otherwise, okay, come to compilation, got problem. Okay, so these two are connected to here. Subsequently, their output for this bin BCD is not the output for the whole thing yet. Okay, but it's the output for this particular bin BCD. So the interface of this one here now, this one, I go to here. The 2 here, bin 2, I come to here. And with that, okay, I'm going to get my output for the top level. So once you finish drawing all this, okay, or sorry, draw the lines, the wiring, everything's okay. Please compare. Okay, please compare to check for any syntax error. Okay, so once you compare, you won't be getting this. Cannot see this, okay. Now I compare, make sure it works properly already. Then actually, I can only get this one, okay, after I do all my pin assignment under this parts here. Okay, under this part here, I tell them that A3 connect to where, okay. Say for example, this is A3, I want to connect to sorry, C1 first, okay. C in, the C in, I make it connect to pin B13, okay. This pin B13 is a key, okay. Key, where is my key? Input, okay. C in, can I know it's a bit small, okay. Let me enlarge first. Okay, now the C in, I assign to pin B13. Clock, I assign it to pin G26. Now, it's not suka hati I pick one. When I decide, okay, that my C in, I want to use the key. Okay, key means it's this one. Okay, I decide, okay, my C in, I want to use this one, whereby I can push, okay, button. It's a push button. All right, then I check, okay, what is the label or what is the pin number for all these keys here. I just pick one. And in this case here, I pick, okay, pin B13. And for the case of a clock here, okay, I also actually using key, okay. Clock, yeah, I use key, okay. Could be it's a second key, and then it is given by, okay, out of the another leftover, I pick G26. Randomly, I pick anyone. All right. So with this, okay, I pick for all. Okay, one by one, I pick all the input. All right, and this is the output. Output, okay, is actually here. Up to you. You can pick this one. This is the hex 0. They call it hex. Okay, hex 1, hex 2, hex 3. But it's actually a 7-segment display. All right. So in this case here, the 7-segment display, they call it digit 1, pin number 6, 5, 4, and so on. So instead of ABC as a standard VHDL here, they use 0 to 6. Or actually it's 7 bit, isn't it? All right, 7 bits here. Of course, sometimes, okay, we are not sure that whether this is a A or G. It's always only A or G only. You can test one. So when you compare the time, how come the result come out very funny? Then just validate it. Because there's no clear say that, okay, which is A, which is G. So we try once, then we will know. And often now, I can't remember that whether this is A or this is G. All right. So just go according to this, okay, when come to the hardware downloading part. Same thing, digit 2. All right. Either A or G for these two, then we test out. So once, okay, I key in all these under my pin planner here. Okay, this is the pin planner part. Then you find that, okay, I need to compare again. Okay, I need to compile again. After the comparison, this thing will appear. Okay, you find that, okay, I can, okay, so 4 bit, so 1, 2, 3, 4. Okay, so this one you can pull if you want. Okay, pull, then you find the 4 pins and you can double check whether it is correct or not. All right, of course, the double check here refer to the standard table that provided, okay, by quarters 2. All right, so this thing will come out to indicate that there are actual connections to the hardware. Okay, then when we connect this hardware at the time and we press the key, okay, we press the key here. Okay, you press the key here, you are going to find out, okay, the number here will be changing if we put in different setting. Okay, so these are 4 here is my A input, another 4 my B input, then this one here my C in. Of course, if you don't like this arrangement, you can start from here. Suka hati ya, all right, you can start from here. Okay, we use the switches here. Push up, logic 1. Push down, logic 0. All right, so when I change this one here and I press the clock in control manually, then you find that the number will appear here. All right, to indicate that this program is correct or not, you can double check with your B, A, and your carry in all sum together and convert them into decimal. Okay, so this is the whole programs of this. And in this DE2 board here, remember when we do the assignment at time, the Cyclone 2. Now this is the Cyclone 2. Okay, so not clear, not very clear. Okay, this is a Cyclone 2. So all connections, okay, has been connected. Okay, I mean at the bottom here to all these parts here. So this is the heart of this DE2 board. Okay, you can actually connect to the external if you want to for project purpose. Okay, have your own I/O pin, input and output pin. All right, this is the power. This is the one that connect to your computer. Okay, the broadcaster, so that, okay, program can be downloaded. So if we go to the lab, okay, we'll let you experience this one. All right, and next I want to tell here is if you go to the classroom under the recording part, DSD lecture recording part, you'll find that, okay, I will put in the DE2 download. Okay, sound quality is not very good, but all the process of downloading can be seen here. Okay, so next week when we do it at time, okay, we can just follow the steps and to test, okay, the program that you're done so far, okay, is it correct? Okay, so I stop recording. Okay, so any questions? Now, of course, if no question, we carry on. Okay. How to force the stimulus at the input pin? You are talking about this page 26, is it? Let's check. Are you referring to this? Are you referring to this, Adin?
Yes, yes.
So you can copy. Or maybe, okay, I copy this one, put into the, oh no, you can copy, okay, and you directly, okay, when you see this VSyn, may not be 94. So this VSyn can be any values, okay, you just copy the whole thing and throw it in. Clear to you?
Okay, got it.
Okay. Of course, okay, in my case, I normally, okay, prepare a notepad. I have this notepad, okay, copy into a notepad. Then directly I just throw everything in. So any changes I want to make, I make in the notepad first. Okay, I hope you all understand what does it mean by this one. I start off my carry in, C in, carry in here, start from 0. You can see, okay, this result here, okay, when you pull this one, okay, make it a little bit larger. And the output here, okay, because it's in 7 segments, so it's a bit difficult to understand now. But at least, okay, you can show you. Anything goes wrong with this 7 segment here, very easy to change. You just go back to the segment, change the 1 to 0 or 0 to 1. Then compile everything again and repeat. All right. So now, if there's any question, okay, please ask here. And those who have done, okay, can see the video. So I didn't manage to get the result same as mine. Okay, good. So hardware downloading part cannot do. So you see the video lah. See the video first, ah. Then think of your assignment. Now, class, the assignment is 2 person in a group. And again, okay, because your list group here is odd number, so only one group can have 3 person. And let me know which is a group having 3 person. Now, the assignment here is all using VHDL. You got to write, cannot draw. Because in the exam, there's no such thing as draw the plot diagram, okay? But here, because we are learning the quarters 2, since quarters 2 having this feature, no harm introduce it to your. All right, then the writing part of the code, okay, is being enhanced during your tutorial as well as this coming assignment. So form your own group, 2 person in one, then start your assignment. I thought already released. Let me check. Okay, let me check. Base, okay. Oh, belum. Okay. Let me check. Okay, so I miss out this part. No problems. I have it ready. Two, three. Or did I put it here? Okay, this is the one. Okay, can see the assignment, Adi? Now you will see, okay, this assignment here actually require you to do a little bit of a presentation. But if condition getting worse, okay, then I may need to change this marking rubric. Okay, marking rubric is at the back there. Report format. Okay, so we talk about this one next time. All right. So the lab assignment is already in the inside the G drive, under the notes and the tutorial. Okay, same folder. Assignment is answer using quarters 2. Right. Everything is right. Okay, the VHDL code means that, okay, you cannot do drawing. Okay, why force you to write? Because exam, okay, is writing. Okay, not drawing. You can have a schematic to show your explanations. Anyhow, okay, because this is an assignment, so you need to explain your code thoroughly. All right, so you can form your block diagram. But all questions, okay, if you read the question carefully, always I use the word start off with right. Okay, write the VHDL code for this and for that. Okay. Well, the rest today are very quiet. Are you okay, Brian? Brian, okay, Ren Jian? Ren Jian, are you all right? Okay, Song Jian, your stomach okay already? So Jian is a half slap, Mm. Still dreaming, okay? Going, all right. So try to get it done, okay? Everything by today. Mm. Then why? No problems with you, right? You later. Yeah, later got 1 hour lecture, isn't it? So later the 1 hour lecture, we can finish our VHTL topics already. So you don't want to have lecture, Kok Wing? Or because you can't follow Monday lecture, haven't see the video yet. John, all right with you, Uh, now, are we going to have lecture, okay, straight away after the lab? Okay, depends on your. Have you taken your breakfast? Or tomorrow very good, okay, always okay, the first to join the class, for morning class. Wake up very early, okay? Okay, want to terus, okay, terus 1 hour. Today, okay, we can end a little bit earlier. But after finish my BHCR, maybe okay, we do a little bit revisions on Kanomat. So we terus, okay. So today end at 11. Okay, continue with your breakfast can, okay, you can eat one listen, okay. So do two things at the same time. In my case, I can't, okay, because I keep on talking. So okay, try to get it done. I stop here. Any question, please ask. So I off my mic. Okay, class, I'm going to take a 10 minutes break, okay? Stretch my body a bit. Then we continue at 10 a.m. Now, if you haven't finished, of course, okay, try to get it done, okay, after this lab here. And next week, okay, you still can ask, okay, if you have any problems. All right, so I stop here for a while. So I'm going to leave here.